So in this video, we're going to talk about resonance. So we're going to talk about resonance structures. And the idea is that if given a molecule on an exam, how would you draw the resonance structure of the compound that you're given? How would you draw a resonance structure of the compound if you're given it on the exam? So this is the first question that we have, and we're going to talk about how do we draw a resonance structure of this compound. Now, the first thing I want to keep in mind, one of the important things I want to keep in mind, is that I'm going to talk about kind of the three places where it serves as electron source. So they're electron sources, right? And the reason why you need to know the electron sources is that because these are the places that you usually start off moving electrons from. Right, so these are the places that you usually start off moving electrons from, and these are places that have negative charges. These are also places that have lone pairs and double bonds. Triple bonds, again, are included in this as well, right? So triple bonds, double bonds, but these are usually the three most common places that serves as electron sources, right? So what that simply means is that resonance structures is the idea if you representing a molecule, you're representing the molecule in the same form. There's nothing that changes about the bonding pattern. Mostly what you're doing is moving electrons, and a consequence of usually moving electrons is that sometimes you may create charges even though the overall charge of the molecule must remain the same. So in other words, we're using this as an example. When we draw a resonance structure of this molecule, right, the overall charge of the resonance structure must be equal to a negative charge like we see here on this first structure. So again, we know what our electron sources are, the common sources. So in this case, we actually see a source, right? In this case, it will be in a negative charge. Now we also see double bonds, but you usually want to start with negative charges first. Now, this is telling us that the carbon has an extra lone pair by its side, and so this is why it's actually negative. So what I can actually do is take the lone pairs, form a double bond. Simultaneously, because they form a double bond, now this carbon has 5 bonds. The carbon adjacent to it has 5 bonds. So that means that, in other words, I'll have to move a double bond to the opposite side of this carbon, right? In that process, I also form a double bond, and so this carbon has 5 bonds around it, which is not possible in organic chemistry. Now remember, in organic chemistry, you have to recognize that we do not always give you the lone pairs, but we know that since this oxygen is neutral, it is assumed that 2 pairs of lone pairs is on it. This is the reason why it satisfies the octet rule. Now, because this carbon has 5 bonds at this point, we'd actually take one of these from the double bond. We could take a single bond and actually put in the form of lone pairs on this oxygen, right? So let's recap what we actually drew. We still have our hydrogen. This is now bonded to a carbon that now has a single bond to 3 pairs of lone pairs. In the process, I still have a double bond, because remember, we form a double bond right there, and we have a double bonded carbon that still has its hydrogen that is bonded to another carbon which still has its hydrogen, but now it's double bonded like the arrow is showing to or CH2. And so in other words, the negative charge moved all the way from this carbon to this oxygen. Notice that the bonding pattern okay, it may change with respect to, okay, well, we may be looking at a triple bond, a single bond instead of a double bond, but all we're doing is actually moving electrons. Notice that the overall charge of the molecule is still negative, like we started with. So this will be a plausible resonance structure for the molecule on the left. Right? And you actually see there's no more resonance structure that we can actually draw with the first one. How about this one? How about this one? Remember, organic chemistry is tough in the fact that whenever you see a negative charge, you have to make sure you fill in your lone pairs, and that's the only way you could actually kind of see where we're going. Now remember, we gave you the most common sources of electrons. Mostly, the negative charges are usually the ones you usually start with. If there are no negative charges, then you may look for lone pairs. If there are no lone pairs, then you may look for double bonds. Right? So because this oxygen is negatively charged, that tells me that this oxygen has a single bond with 3 pairs of lone pairs around it. And this is coming from general chemistry. So to draw a resonance structure, right, what I'm going to do is take one of these lone pairs, form a double bond by this carbon. But now this carbon has 5 bonds, so I can actually take one of these double bonds out of the ring and actually situate on one of the carbons. And so what does this give me? This gives me a resonance structure that looks like this. I still have these structures, but now I have a double bond to an oxygen that now has 2 pairs of lone pairs. And I have a lone pair on this carbon, right, making this carbon negative. Notice that the charge still remains a conservation of charge. We didn't change the charge, right? It didn't go from negative to 0 or negative to positive. It's still negative. Now you might be wondering to yourself, can we actually draw another resonance structure? And the idea is yes, right? I can actually take this lone pair and form a double bond in the ring, and I can actually take this double bond as a single bond and form a lone pairs on this carbon, right? So at this point you actually see how I'm actually just rotating the negative charge around the ring. And so I still have my double bonded oxygen, right? Now I have a double bond at this spot, but now I have a pair of lone pairs on this carbon. In fact, it is now negatively charged with this still remaining like that. Now you may ask yourself, can we draw another resonance structure? And the idea is sure. Right? I hope you're seeing this. I could actually take this pair of lone pair, form a double bond here, and then move this double bond, move the single bond here rather, to form a double bond in this side. Well, I'm sorry, excuse me, not a double bond, because that would give this carbon 5 bonds, but I'm sorry, right, on this carbon I can form a lone pair on that carbon, so excuse me, right? So this becomes this. I still have my double bond here, I still have my double bonded oxygen here, but now I have a lone pair on that carbon, and that's negatively charged. Now remember, I still have my double bond here as well. Can you draw another resonance structure? Most likely not. If you draw another resonance structure, you're going to end up at this structure that we essentially, the first resonance structure, right? So you could see that again, the only thing we're doing is moving the negative charges around the ring. In this case, again, we start from electron source, which is usually a negative charge, then we move down the line. How about this one? Pause the video and try to do this one. How would you draw a resonance structure of this molecule? Now remember, we said that negative charges are electron source, so that's usually where you're going to start off moving your electrons from. However, we do not have any negative charges here. We do not have any double bonds, right? But remember, again, organic chemistry is difficult. We didn't draw the lone pairs, but remember that there's actually 2 pairs of lone pairs. And I'm sorry, I forgot a double bond. I forgot a double bond here. But there's 2 pairs of lone pairs on the nitrogen. We also have a double bond here, which I forgot in the molecule in the structure. But originally we have that is a structure. So how do we draw a resonance structure of this compound? Well, the first thing I'm going to do is to actually move starting from electron source, right? Now in this case, I'm going to start from the lone pairs, right? Again, lone pairs are usually electron source. Again, you get those from negative charges, but also again, if there's no negative charge, then you look for the lone pair somewhere else. And then lastly, we look at the double bonds, right? So I could actually take this lone pair and form a double bond within the ring, but that will give this carbon 5 bonds. So I can actually take this double bond and put it on this aspect. Right, notice I'm moving it to the adjacent carbon. So what is the structure that results? Now I have a double bond to this nitrogen, and now I have a double bond right here. Right? Notice that this is still positively charged. Right? So notice that my nitrogen is still positively charged. So essentially we move the positive charge from the carbon to now it's on the nitrogen. And you would see that you can't really draw any more resonance structure for this molecule. And that's how we draw resonance structures.